Hello, in this lecture we will find out the diameter of the semicircle. In the drawing we have a semicircle. We know that side of the line segment AD of the semicircle equals to 7 units. Line segment DC equals to 15 units. Line segment BC of the inside the semicircle equals to 15 units, and we also know that AB is the diameter of the semicircle, and we want to find out the size of the diameter AB of this semicircle. Okay, so first of all we will make a construction. We will connect together points D and B by a straight line. So actually DB is a straight line. And we have a rule, I will call it rule number 1. According to rule number 1, the peripheral angle resting on the diameter of a circle equals to 90 degrees. Okay, the peripheral angle resting on the diameter of a circle. It can be circle or semicircle. The peripheral angle resting on the diameter of a circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that the peripheral angle resting on the diameter of a circle equals to 90 degrees. Okay, so actually here we have, so any peripheral angle that rests on the diameter of a circle is equal to 90 degrees, and here we have angle ADB, that is a peripheral angle that rests on AB, that is the diameter of a circle. AB is the diameter of the circle, of the semicircle. So actually angle ADB rests on the diameter of the circle, and according to rule number 1 it equals to 90 degrees. So this angle equals to 90 degrees according to rule number 1. So we can say that angle ADB equals to 90 degrees according to rule number 1, because it rests on the diameter of the circle, that is AB. Okay, then we will also define the center of the semicircle as point O. O is the center of the semicircle. Then we will join together points O and C by a straight line. And then we will join together points O and D by a straight line. And we will focus on two triangles. We will focus on triangle OCD, that is the green triangle, so we will focus on the green triangle OCD, and we will also focus on the orange triangle OCB. Okay, we will focus on the green triangle OCD, and we will also focus on the orange triangle OBC. Okay, so in triangle DOC, and triangle BOC, we know that DC equals to BC equals to 15 units. It is given us in the question. DC in the green triangle equals to BC in the orange triangle. Both of those two sides are equal to 15 units. DC equals to BC equals to 15 units. And we know that OD will define the radius of the semicircle as R. Okay, so OD is the radius of the semicircle because it exists from the center of the circle, that is point O, and ends at point D, that is a point on the circle itself. Therefore, OD is the radius of the semicircle. And also, from the same reason, OB is also the radius of the semicircle because it exists from the center of the circle and ends at point B, that is the point on the circle itself. Therefore, OB is the radius of the circle. So, OD equals to OB equals to radius of the circle. OB or OD, side OD of the green triangle equals to side OB of the orange triangle. Both of those sides are the radiuses of the circle. Okay, radiuses of semicircle. Okay, OD equals to OB equals to R, that is the radius of the semicircle, and OC equals to OC, it is a common side. OC equals to OC, it is the common side. It belongs to the green triangle and also to the orange triangle. Common side. So we actually found that 3 sides of the green triangle are equal to 3 sides of the orange triangle. Therefore, we can deduce from it that the green triangle is congruent to the orange triangle. Okay, so therefore triangle COD, the green triangle, is congruent to triangle OCB, the orange triangle. Okay, so the green and the orange triangles are congruent to each other. Therefore, angle OCD will be equal to angle OCB. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So angle DCO is equal to angle OCB. Okay, so if we define angle DCO as alpha, then angle OCB that equals to angle OCD also will be equal to alpha. Okay, so those two angles are equal to alpha. Okay, so angle DCO equals to angle OCB equals to alpha. Now we will focus, first of all, we define this point as point E. And we will focus on triangle DCB. Okay. So on triangle DCB, DC equals to CB equals to 15 units. From that equality we can deduce that also this angle equals to this angle, according to the rule that states that in front of equal sides in a triangle there are equal angles. Okay, we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. Okay, again, rule number 2 states that in front of equal sides in the triangle there are equal angles. Okay, so therefore this angle is in front of DC that equals to 15 units. This angle is in front of BC that also equals to 15 units. And according to rule number 2, the angles that are located in front of equal sides are also equal to each other. So therefore those two angles are equal to each other. So if we define this angle as theta, then this angle will be also equal to theta. Okay, so according to rule number 2, angle EDC this angle equals to angle EBC and both those two angles are equal to theta. Okay, this is according to rule number 2. Again, angle EDC equals to angle EBC equals to theta. Those two angles are equal to each other and both angles are equal to theta. Okay, according to rule number 2. And actually now we will focus on two triangles, on triangle ECD and triangle ECB. Okay, we will focus on those two triangles. We know that DC on the green triangle equals to BC on the orange triangle. DC equals to CB. Both of those two sides are equal to 15 units. We also know EC is the common side, so EC equals to EC. It belongs to both to the green triangle and to the orange triangle. EC equals to EC, the common side. And angle ECD in the green triangle equals to angle ECB in the orange triangle. We found out that both those two angles are equal to alpha. Okay? Okay, so in those two triangles we have DC that equals to CB, DC equals to CB. We have also EC that is a common side, and we also know that angle DCE equals to angle ECE. Both those two angles equals to alpha. So we actually found out that two sides and one angle in the green triangle are equal to two sides and one angle in the orange triangle. Therefore, those two triangles are congruent to each other according to the rule of side angle side. If you have two sides and the one angle in one triangle that are equal to two sides and one angle in the other triangle, then those two triangles are congruent to each other. So if two sides and the angle between them of one triangle are equal to two sides and the angle between the two sides in the other triangle, then those two triangles are congruent to each other according to the rule of side angle side. So triangle DEC is congruent to triangle EBC according to the rule of side angle side rule. Okay, so triangle DEC is congruent to triangle EBC according to side angle side rule. Okay, again, if you have two sides and the angle between those two sides in one triangle that are equal to two sides and the angle between those two sides in the other triangle, then those two triangles are congruent to each other. Therefore, those two triangles that have two sides and the angle between those two sides that are equal to each other, they are congruent to each other. Those two triangles are congruent to each other. Okay, so therefore we can first of all deduce that ED on the green triangle equals to EB on the orange triangle. ED side ED of the green triangle equals to side EB of the orange triangle, according to the rule that states that corresponding sides in congruent triangles are equal to each other. So ED equals to EB. And we also can deduce from the fact that those two triangles are congruent to each other that angle CED in the green triangle is equal to angle CEB in the orange triangle. Okay, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so angle CED in the green triangle equals to angle CEB in the orange triangle. So if we define angle CED as x, if angle CED will be defined as x, then angle CEB also will be equal to x. Okay, so actually, so the sum of the two angles will be equal to x plus x. Okay, so angle CED plus angle CEB will be equal to x plus x, that is 2x. Okay, x plus x is 2x, so this angle, actually this angle is actually x plus x. So actually we can say, and we know that DB is a straight line because it is one side of the right angle ADB. Okay, so side DB is a straight line. Therefore, first of all, we know that angle DEB equals to x plus x. So from one side, angle DEB equals to 2x in its size, But from the other side, because of the fact that DB is a straight line, it is one side of a right angle, angle ADB is a right angle, it is one side of the angle ADB that is a right angle, so DB is a straight line, therefore angle DEB is equals to 180 degrees. Because of the fact that DB is a straight line, then angle DEB will be equal to 180 degrees. Okay, so we know that angle DEB equals to, from one side to 180 degrees, and from the other side angle DEB equals to 2x. So from this equality we can deduce that 2x equals to 180 degrees. Okay, 2x equals to 180 degrees. And if we divide this equality by 2, we will get that x equals to 180 degrees over 2 is 90 degrees. X equals to 90 degrees. So angle DEC is actually x equals to x according to our definition. So this is the right angle. And angle CEB is also equals to x according to our definition, and found out that x equals to 90 degrees. So this is also a right angle. Okay? But we also know, okay, so here, because of the fact, as I already told you, because of the fact that DB is a straight line, and this angle DEB equals to 180 degrees. Okay? But we also know that OC is the radius of the semicircle, because it starts from the center of the circle and ends at point C, that is a point on the circle itself. So OC is the radius of the circle, therefore it is a straight line. So OC is a straight line. OC, that is the radius of the circle, is a straight line. Therefore, you can deduce from it that angle CEO equals to 180 degrees, because OC is a straight line. Therefore, angle CEO equals to 180 degrees. Okay, so this angle equals to 180 degrees. Okay? But we know that angle CEB equals to 90 degrees. And in total, this angle equals to 180 degrees. Therefore, angle OEB, this angle will be equal to 180 degrees minus 90 degrees. In total, this angle is 180 degrees. And we know that angle BEC is 90 degrees. So what is left here is that this angle must be equal to 180 degrees minus this angle that is 90 degrees. 180 degrees minus 90 degrees equals to 90 degrees. So this angle OEB equals to 90 degrees. Okay? Again, angle OEB equals to the this angle that is 180 degrees minus this angle, because angle OEB is 180 degrees. So this angle plus this angle equals to 180 degrees. So 180 degrees minus this angle that is 90 degrees must be equal to this angle. So 190 degrees minus 90 degrees equals to the size of this angle that is actually 90 degrees. So angle OEB equals to 90 degrees. So around point E we have 3 right angles, and we know that the sum of the angles around any point in total equals to 360 degrees. So what will be the size of this angle? The size of this angle will be equal to the sum of the all the angles around this point, that is 360 degrees, minus the sum of those 3 angles, that is 90 degrees times 3, that is 270 degrees. So actually we found out that the size of this angle must be equal to 360 degrees minus 270 degrees, that is actually equals to 90 degrees. So we found out actually that this angle is also a right angle, so all the angles around point E are right angles. Okay? So actually in the next step we'll focus on 2 triangles, on triangle ADB and on the small triangle, triangle OEB. Triangle OEB. Okay? We will focus on triangle ADB, the big triangle, and on the small triangle, triangle OEB. I will draw those 2 triangles again. We have triangle ADB. We know that angle ADB is a right angle, and we also know that this angle is a right angle. So I draw again those 2 triangles. So on those 2 triangles we have those 2 angles that are equal to each other. Both those 2 angles are equal to 90 degrees. So angle ADB in the big triangle equals to angle BC. Both those 2 angles are equal to 90 degrees. We have angle B that is a common angle. It belongs to both triangles. So angle B equals to angle B. And the third angle, angle DAB, must be also equal to angle EO. Here it is. To angle DAB also must be equal angle DAO. This angle DAO, must be also equal to angle EOB. Okay, angle DAO, this angle must be also equal to angle EOB, to this angle. Why? Because of the rule that if you have two triangles that have two angles that are equal to each other, then the third angle of the first triangle must be equal to the third angle of the second triangle, because of the fact that the sum of the angles in any triangle are equal to 180 degrees, and the third angle completes the sum to the sum of the two angles to 180 degrees. So it is a complementary angle. Therefore, it must be also the third angle in the first triangle must be also equal to the third angle in the second triangle. Okay, because actually if we define the sum of the two angles that are equal to each other as y, then the third angle must be equal to 180 degrees minus y. Okay, but the sum of the two angles in the first triangle are equal to the sum of the two angles in the second triangle. Okay, so if y is the sum of the angles in the first triangle, then y is also the sum of the angles in the second triangle. So the third angle will be equal to the sum of the three angles, that is 180 degrees, minus y. But the third angle is also the third angle, the size of the third angle in the first triangle, and it is also the size of the third angle in the second triangle. Okay, because for example, if the first angle that equals in the both triangle is alpha and the second angle is beta, so the sum of the angles in the two triangles is alpha plus beta, and alpha plus beta is the sum of the angles, so it is the sum of the angles of the two triangles, and 180 degrees minus the sum of the two angles minus alpha plus beta will be equal to the size of the third angle. So 180 degrees minus alpha plus beta will be the angle, the size of the angle in the first triangle, and it will be also the size of the angle in the third triangle. Okay, so actually we found out that three angles on triangle ADB are equal to three angles on triangle BOE. Therefore, those two triangles are similar to each other. Okay, triangle ADB is similar to triangle OEB according to angle similarity. According to angle similarity. Okay, so those two triangles are similar to each other according to angle similarity. Okay, so from this similarity we can derive the following relationship between the sides of the two similar triangles. We can say that AO over AB equals to OE over AD. Okay, because of the fact that those two triangles, triangle ABD and triangle OEB, are similar to each other, the following relationship, the following equality is true between the sides of those two similar triangles, that AO over AB equals to OE over AD. But what is the size of AO? What is the size of AO? AO is the radius of the semicircle, because it starts from the center of the circle and touches the circle at point A, and this is the definition of a radius. So AO is the radius of the semicircle, and what is, so AO equals to R, and what is the value of AB? AB equals to R plus R. AB equals to R plus R. So AB equals to 2R, all equals to OE. What is the value of OE? OE, we will leave it as it is, over AD. What is the value of AD? AD equals to 7 units. 7 units, it is given us in the question. So in total we got that R over 2R equals to OE over 7. R over R is 1, so R is cancelled. So in total we got that 1 over 2 equals to OE over 7. 1 over 2 equals to OE over 7. Here we will multiply the equality by 7, and we will get that 7 over 2 equals to OE. Okay, or in other words, OE equals to 7 over 2. Here OE equals to 7 over 2 units. And what is the value of CE? CE equals to OC minus OE. Again, CE equals to OC minus OE. Okay, 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 CE equals to OC minus OE. But what is the value of OC? OC is the radius of the circle, because it starts from the center of the circle and touches the circle at point C. So OC equals to R. OC equals to R, so CE will be equal to OC, that is the radius of the circle, minus OE, that we've already found out, that equals to 7 over 2. So in total, we found out that CE equals to R minus 7 over 2 units, okay? Here, CE equals to R minus 7 over 2 units, okay? So, in the next step, we will focus on two right triangles. Triangle CEB is a right triangle because this angle is a right angle, and triangle OEB is a right triangle because angle OEB is a right angle. So we can implement the Pythagorean theorem in the two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we will create the equality that states that EB square equals to EB square. EB square equals to EB square. Okay, we have the equality that EB square equals to EB square, but actually EB is a side that is a common side. EB belongs to the right triangle EBC, this triangle, and EB also belongs to the right triangle EOB. So we can implement two times the Pythagorean theorem and on the two right triangles. So here we will substitute EB by its value on the right triangle CEB, and here we'll substitute EB square by the value of EB square according to the right triangle EBO. So actually EB square, if we relate to this triangle CEB, will be equals to CB square minus EC square. This is from this side of the equation, and EB square is also belongs to this right triangle, so it will be equal to OB square minus OE square. It equals to OB square minus OE square. Okay, so in total we got that CB square minus EC square equals to OB square minus OE square. But what is the value of CB? CB equals to 15, so CB square is 15 square. 15 square is 225 minus EC square. EC equals to R minus 7 over 2, so EC square will be equal to R minus 7 over 2 square. All equals to OB square. OB equals to R, so OB square is R square minus OE square. OE equals to 7 over 2, so OE square is 7 over 2 square. So in total we got the 225 minus R over 7 over 2 square equals to R square minus 7 over 2 square. Here 7 over 2 square equals to 94 over 4. 7 over 2 square equals to 49 over 4. And here we'll open the brackets. we will get that 225 minus r minus 7 over 2 square is r square, plus 7 over 2 square is 49 over 4, minus 2 times r times 7 over 2 equals to r square minus 7 over 2 square is 49 over 4. Okay, so in total we got this expression. Here we will open the brackets. We will get that 225 minus r square minus 49 over 4. Here we have 2 in the numerator and 2 in the denominator, so 2 is cancelled, and we have minus 7r. Minus 7r is plus 7r equals to r square minus 49 over 4. Okay, so here we have 49 over 4 minus 49 over 4. On this side of the equation we have minus 49 over 4 in the other side of the equation, so we can cancel minus 49 over 4. And we will add r square to this equality, and we will get that r square here minus r square plus r square is 0. So what is left here is 225 plus 7r equals to 2 times r square. Okay, so in total we got that 2r square equals to 7r plus 225. So here we'll subtract 7r and 225 from this equality, and we will get that 2 times r square minus 7r minus 225 equals to 0. So we have this quadratic equation. It states that 225 minus 7r minus 2 times the radius square minus 7r minus 225 equals to 0. So here we have quadratic equation. The coefficients of the quadratic equation are as follows: a equals to 2, b equals to minus 7, and c equals to minus 225. Okay, and we have general solution for any quadratic equation that states that x equals to plus minus x equals to minus b plus minus root of b square minus 4 times a times c over 2 times a. Okay, so this is the general solution for any quadratic equation when the variable is x. Here our variable is r. So x equals to r. Okay? So x equals to r. So here we will substitute b by minus 7, c by minus 225, and a by 2. Okay? And we will get that r equals to minus b equals to minus 7, so minus 7 is plus 7, plus minus root of b square is minus 7 square is 49, minus 4 times a is 2, times c is minus 225, over 2 times a is 2 times 2 is 4. So in total we got that the radius equals to 7 plus minus 49 minus 4 times 2 is minus 8, and minus 8 times minus 225 is 1800. Okay, so I write it down. In total we'll get that r equals to 7 plus minus root of 49 plus 1800 over 4. So r equals to 7 plus minus root of 1849 over 4, or r equals to 7 plus minus the root of 1849 is 43 over 2. So in total we got that r equals to 7 plus minus 43 over 2. So we have the first possibility that r equals to, first solution, that r equals to 7 plus 43 over 4. Here I made mistake. It is divided by 2a, that is 4. So it is here divided by 4. Okay, we divide it by 4 and not by 2, so it is 7 plus 43 over 4. 7 plus 43 is 50, and 50 over 4 is 12.5. So the first solution is that the radius equals to 12.5 units. The first solution to the quadratic equation is that the radius of the semicircle equals to 12.5 units. But we have also, we should not forget also the second solution to the quadratic equation. The second solution is that r equals to 7 minus 43 over 4. 7 minus 43 is minus 36 over 4. Minus 36 over 4 is minus 9. So we got that the radius equals to -9. But because of the fact that the radius must be a positive number, this is not a correct answer, so we will delete this possibility. We'll cancel this possibility. R equals to -9 is not possible, and we left only with the first solution to the quadratic equation, that is actually states that the radius of the circle equals to 12.5 units. Okay, the radius of the circle equals to 12.5 units, and the diameter of any circle equals to 2 times the radius of the semicircle. So the diameter is 2 times the radius. D, that is actually equals to AB, is 2 times the radius. 2 times the radius is 2 times 12.5. That is to say, it equals to 25 units. So the answer to the question is that D, that equals to AB, that is the diameter of the semicircle, equals to 25 units. Okay, the diameter of the circle that equals to AB, AB, that is the diameter of the circle, equals to 25 units. That is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle. We know that AD equals to 7 units, BC equals to 15 units, BC equals to 15 units, and DC equals to 15 units. And again, AB is the diameter of this semicircle, and we want to find out the size of the diameter of this semicircle that is equals to AB. Okay. So first of all, we draw reconnected points D and B by a straight line. DB is a straight line, and then we actually have a rule. I called it rule number 1. Rule number 1 states that the peripheral angle resting on the diameter of a circle equals to 90 degrees. Okay, again, the peripheral angle resting on the diameter of a circle equals to 90 degrees. So actually here angle ADB, this angle is a peripheral angle. This angle is a peripheral angle that rests on the diameter of the circle, that is actually AB. So angle ADB rests on the diameter of the circle. Therefore, according to rule number 1, it equals to 90 degrees. So angle ADB equals to 90 degrees. Okay, then we focused on the green triangle and on the orange triangle. On those two triangles, we know that DC equals to BC equals to 15 units. We also know that OB equals to OD, OD equals to OB. Both those two sides are the radiuses of the circle, therefore they are equal to each other. They are the radiuses of the semicircle, therefore they are equal to each other. And also OC equals to OC, it is a common side. So we actually proved that three sides of the green triangle are equal to three sides of the orange triangle. Therefore, those two triangles are congruent to each other according to the rule of side, side, side. If you prove that three sides of one triangle are equal to three sides of the second triangle, then those two triangles are congruent to each other. Okay? So, okay, the green triangle is congruent to the orange triangle. Okay, so therefore those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So angle OCD equals to angle OCB. Those two angles are equal to each other. We defined angle OCD is alpha, therefore angle OCB also equals to alpha because they are equal to each other. Okay, angle OCD equals to angle OCB equals to alpha. And then we focused on triangle DCB, on this triangle, triangle DCB. We know that in triangle DCB, BC equals to DC. Those two sides are equal to each other. Both of those two sides are equal to 15 units. Okay? And we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So those two sides are equal to each other, and according to rule number 2, in front of equal sides there are equal angles. So in front of this side we have this angle, and in front of this side we have this angle. So according to rule number 2, those two angles are equal to each other. Okay, so according to rule number 2, angle EDC equals to angle EBC, and we defined angle EBC as theta, therefore this angle that equals to angle EBC also will be equal to theta. Okay, and then we focused on triangles ECD, this triangle, and on triangle ECB. We focused on those two triangles. On those two triangles, we know that DC equals to CB. Both of those two sides are equal to 15 units. EC equals to EC. It is common side. It belongs to those both triangles. So they have common side. So EC equals to EC. And we know that angle ECD equals to angle ECB equals to alpha. Those two angles are also equal to each other. So we have two sides and angle between those two sides. The angle between those two sides are equal between those two triangles. Or two sides, those two sides and the angle between those two sides are equal to those two sides and the angle between those two sides. Therefore, those two triangles are congruent to each other according to the rule of side angle side. Okay, so triangle DEC is congruent to triangle ABC according to the rule of side angle side rule, and therefore, from the fact that those two triangles are congruent to each other, you can deduce that ED equals to EB, and also angle CED, this angle, is equal to angle CEB, to this angle. Okay, those two angles are equal to each other according to the rule that the corresponding angles in congruent triangles are equal to each other. Okay, and we define angle CED as x. This angle is defined as x, therefore this angle, that is actually CEB, also, that is actually angle CED, also is defined as x. Okay, angle CED equals to angle CEB, and both those two angles are defined as x, they are equals to x. So actually the sum of those two angles is x plus x. X plus x equals to 2x. So those two angles, the sum of those two angles equals to 2x. So actually angle DEB, this angle is equals to 2x from one side, but because of the fact that angle DEB is because of the fact that DB is a straight line, therefore angle DEB also equals to 180 degrees. Okay, so from one side angle DEB equals to 180 degrees, and from the other side angle DEB equals to 2x. So from this equality we can deduce that 2x equals to 180 degrees, and if we divide this equality by 2 we will get that x equals to 90 degrees. Okay, so x equals to 90 degrees, that is to say angle CEB equals to 90 degrees, and also angle CED equals to 90 degrees. Okay, so those two angles are both equals to 90 degrees. And we also know that OC, that is the radius of the semicircle, is also a straight line. OC is a straight line, therefore angle CEO equals to 180 degrees, because CEO is a straight line, therefore angle CEO equals to 180 degrees. Okay, so from one side we know that angle CEO equals to 180 degrees, but we also know that angle CEB equals to 90 degrees. We have already found out that angle CEB equals to 90 degrees. So what will be the size of this angle? It must be equal to 180 degrees minus this angle, that is 90 degrees. Therefore, this angle must be equal to 180 degrees minus 90 degrees, that is also 90 degrees. Okay, so we found out that around point E we have 3 right angles, that in total they equal to 270 degrees. And we know that the sum of the angles around any point equals to 360 degrees. So the missing angle here, in order to complete the sum of the angles around point E to 360 degrees, is 90 degrees, because we have already three angles that are equal to 270 degrees, and in order that the sum of the angles around point E will be equal to 360 degrees, this angle must be equal to 90 degrees. Okay, because we know that in total the sum of the angles around point E is 360 degrees, minus the sum of the 3 right angles is the angle, the size of the angle that is missing, that is actually equals to 90 degrees. So we actually found out that all the angles around point E equals to 90 degrees. Okay, so then we focus on triangles ADB and the small triangle BEO. We focus on the two triangles, triangle ADB and triangle OEB. Okay, on triangle OEB and triangle ADB. We know that in those two triangles, those two angles are equal to each other. Both of those two angles are equal to 90 degrees. And they also have a common angle, the angle that belongs to both triangles. So they have two angles that are equal to each other. Therefore, the third angle must also equal to in both triangles, because it completes the sum of the angles to 180 degrees. And if, for example, the sum of the two angles is y, then 180 degrees minus y will be the size of the third angle, and it will be 180 degrees for the first triangle, and it will be also 180 degrees minus y for the small triangle. Okay, so therefore the third angle must be also equal in both triangles. Therefore we actually found out that three angles in one triangle, in the big triangle, are equal to three angles in the small triangle. Therefore those two triangles are similar to each other. Okay, according to angle similarity. Therefore they have a special relationship between their sides because of the fact that they are similar to each other. According to the rule AO over AB will be equal to OE over AD. Again, AO over AB will be equal to OE over AD. But we know that AO is the radius of the circle, so it equals to R. And AB is the diameter of the circle. AB equals to R plus R, so AB equals to 2R. Okay, we substituted AO by R and AB by 2R. And we also know that AD equals to 7 units. It is given us in the question, so we substituted AD by 7 units. Okay, so here we have R over R is cancelled, and we got in total that 1 over 2 equals to OE over 7. And we found out that the size of OE is 7 over 2 units. And what is the size of CE? The size of CE is OC minus OE. Again, OC, EC equals to OC. Again, EC equals to OC minus OE. Okay, EC equals to OC minus OE. But we know that OC is the radius of the circle, so OC equals to R. And OE equals to 7 over 2. We found out that OE equals to 7 over 2 units. So we substituted OC by R and OE by 7 over 2, and we got that CE equals to R minus 7 over 2. Okay, EC equals to R minus 7 over 2. And then we have here two right triangles. Triangle CEB is a right triangle because angle CEB equals to 90 degrees, and triangle EBO is also right triangle because angle OEB is also 90 degrees. So we can implement the Pythagorean theorem on the right triangles, the two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and we have this equality that states that EB square equals to EB square, and actually side EB belongs to both the two right triangles. It belongs to the right triangle ECB, and EB also belongs to the right triangle OEB. Therefore, we can implement the Pythagorean theorem on those two right triangles when EB belongs to those two right triangles, and EB square equals to EB square. So EB square equals from one side to BC square minus EC square, because it belongs to this triangle. It equals to BC square minus EC square from one side, but from the other side EB belongs also to the right triangle OEB. So according to the Pythagorean theorem on the right triangle OEB, EB square will be equal to EB square will be equal to OB square minus OE square. EB square will be equal to OB square minus OE square. Okay, we know that CB equals to 15, so CB square is 225. EC equals to R minus 7 over 2, so EC square is R minus 7 over 2 units. And OB is the radius of the circle, so we substituted OB by R. OB square is R square, and OE is 7 over 2. OE is 7 over 2, so OE square is 7 over 2 square. So the only missing variable here is R. So we solve this equality and we got to a quadratic equation. We have here a quadratic equation, and the coefficients of this quadratic equation is A equals to 2, B equals to minus 7, and C equals to minus 225. And we have the general solution to a quadratic equation that states that the variable x equals to minus b plus minus root of b squared minus 4 times AC over 2a, when capital A, capital B, and capital C are the coefficients of the quadratic equation. So actually, if we have the general quadratic equation that states that ax squared plus bx plus c equals to 0, then this is the general formula for a quadratic equation. As you can see here, capital A, capital B, and capital C are the coefficients of this quadratic equation, and we put the coefficients of the quadratic equation inside this equality to find out, in order to find out the root of x. Okay, so we substituted b by root 7, c by minus 225, and a by 2 on this equality, and we found out that the radius of the semicircle equals to 12.5 units, and we have also the second solution to the quadratic equation, the second root of the quadratic equation. We found also that r equals to -9, but because of the fact that r is the radius of the circle, it must be a positive number, so r equals to -9 is not possible, is not correct, so we cancel this possibility and we only left with the solution that the radius of the circle equals to 12.5 units, and we know that the diameter of any circle equals to 2 times the radius of the circle, so the diameter of the semicircle will be equal to 2 times the radius. The radius equals to 12.5 units, so 2 times 12.5 units equals to 25 units. So the radius of this circle equals to 25 units. Okay, the radius of this semicircle equals to 25 units, and this is actually the answer to the question. Okay, thank you very much.